Parallel line proofs. Now, this is going to take in some of the concepts that we talked about in the previous chapter. We did on proofs, the small section we did on proofs. So, concepts is the transfer property is going to come up. I don't think the reflexive property is going to come up much, but you'll probably see the transfer property every now and then. All right. So, number one, we are given that angle 4 and angle 7 are supplementary. One given. So, angle 4 and 7 are supplementary. Now, we are trying to prove that these two lines are parallel, which means we're going to use some of the concepts from 3.3, using the converse theorem, okay, the corresponding angle converse theorem, the alternate interior angle converse theorem, the alternate exterior angle converse theorem, same side interior, same side exterior, yeah. So we can do this, and actually this can be solved two different ways. Okay, it just depends on what you want. We are given that angle 4 and 7 are supplementary. Okay, now when dealing with supplementary angles and trying to prove lines are parallel, what kind of angles do we need to be supplementary for the lines to be parallel? Which angles? Okay, in this diagram, if we know which two angles are supplementary, what that would mean the lines are parallel. You might have an idea. Yes.
3, 5, 6.
5 and 6 would be a linear pair. 3 and 7 would be corresponding. But 2 and 7. 2 and 7. What kind of angles are 2 and 7? No, we can't say so. What relationship do they have? Same side exterior. So if we can prove 2 and 7 are supplementary, all right, then we can say that the lines are parallel. Or what about 4 and 5? Because we have angle 4 and angle 7. We can prove 4 and 5. So that's the two different options here. We can either go with same side exterior with 2 and 7, or we can go with same side interior with 4 and 5. Doesn't matter which one. We are going to need to use the vertical angles though. All right. So let's look at 2 and 7. What is angle 2 congruent to? Which angle is angle 2 automatically congruent? Just by the diagram alone, we know that these two angles, 2 and 1, are congruent because of where they are. If the lines are parallel, we could say that because they'd be corresponding. But we don't know the lines are parallel. We're trying to prove that. Yes. 4. Why is 2 automatically, just based on the diagram, congruent to 4? Because they are vertical angles. Right? So anytime you're given a diagram of two lines intersect, you have vertical angles that are congruent every single time. So we can say number 2, angle 2 is congruent to angle 4 because they are vertical angles. Now, there's a theorem called the supplementary congruence theorem. We learned way back a while ago, 2-3 weeks ago, that says that two angles are congruent, they are supplementary to the same angle. Also, it says that two angles are supplementary to the same angle, they are congruent. So, if angle 2 is congruent to angle 4, and angle 4 is supplementary to angle 7, what else is supplementary to 7? Angle 2 and there's an end, and angle 7 are supplementary. Alright, and that is 3 congruent angles are supplementary to the same angle. Alright, congruent angles are supplementary to the same angle. Now that we know angle 2 and 7 are supplementary, we can say 4 that L is parallel to K. So J is parallel to K. J is parallel to K. Because the same side exterior angles. It's converse. Anytime we're trying to prove lines are parallel, we're going to use that converse. Right. Now again, we could have done this by saying angle 5 and 7 are congruent because they're vertical angles. And then 4 and 5 would be supplementary because the congruent angles are supplementary to 7. So 4 and 5 are supplementary, that is same side interior angle, converse. So again, two different ways to solve this, kind of the same way, but we would be using two different sets of angles. Let's look at number 2. Number 2, we are given, that's nice, we are given that A is parallel to B, which means we can use all those corresponding angles are congruent. We could say same side interior angles are supplementary. We could say alternate interior angles are congruent. Now I'm going to go ahead and put angle 2 is congruent to angle 3 because I like to show just all the given at once. Okay. Now, because we're trying to prove that angle what? 1 is congruent to angle 3. Okay. Now, just because it proves quite a bit, I have yet to here. But anytime we're given that one angle is congruent to another, and I'm trying to prove a third angle is congruent to somewhere, I'm probably going to use that triangle property. So I need a way to prove that angle 1 is congruent to angle 2. And how can I say that angle 1 is congruent to angle 2? What kind of angles? Yes.
Alternative here.
There you go. So angle 1 is congruent to angle 2 because the lines are parallel. And if they are parallel, alternate interior angles are congruent. We didn't really need all the steps here because I think they like to put each given statement on their own line. I don't know why they would like to do that, but they do. So, because we know 1 is congruent to 2 and 2 is congruent to 3, we can say angle 1 is to angle 3 just by that triangle property. All right, we are given that angle 1 is congruent to angle 7. So we're given that. We're trying to prove that angle 4 is congruent to angle 8. Now, there's a couple ways you can do this. Okay, there's only one way you can do this in 3 steps, but there are a couple ways you can do this. One, we know that 1 and 4 and 7 and 8 are supplementary. All right, so we could go with the fact that they both make linear pairs. So 1 is supplementary to 4 and 7 is supplementary to 8 because they make linear pairs. And then if angles are supplementary to congruent angles, then those angles are congruent.
Good morning, everyone. At this time, we are going to begin with the picture retake. Anybody with the last name beginning with A through, you may go to the auditorium for picture retake. Again, any student with the last name A through C may go to the auditorium for pictures.
So, and that's that supplementary angles congruence theorem. So again, we talked about. So we could do that. But the way I think we're going to try to go here is if we know that those two angles, what kind of angles are 1 and 7? We know they are congruent. They are alternate exterior angles, right? Alternate exterior angles. And if alternate exterior angles are congruent, can we say lines L and M are parallel? Yeah. The two alternate exterior angles converse. And that says that L is parallel to M. And if the two lines are parallel, angle 4 and 8 are what kind of angles? They're corresponding. So corresponding angles are congruent. All right, try number 4. So far, some nice simple ones, just a couple steps. So again, you're trying to prove angle 3 and 6 are congruent. Okay. Given that 5 and 8 are supplementary. I mean, there's a couple ways you can do it, but if you're given some angles are congruent, or given some angles are supplementary, you may want to try to prove lines are parallel, and then use the fact that lines are parallel to say that it's congruent. Alright, kind of gave it away. How can I say that lines are parallel because 5 and 8 are supplementary? Are parallel to S because of the same side exterior angles, numbers. And if the lines are parallel, angle 3 is congruent with angle 6 because they are alternate interior angles. We're going to get into some more fun proofs, more steps here. So 5, we're given that C is parallel to D, and angle 1 is congruent with angle 7. So mark that congruent. Alright, so 1 given. Now, I'm trying to prove that lines A and B are parallel. Now, the only ways I have lines are parallel is if I know they're both parallel to the same line, that transit property parallel line. That doesn't happen here because I need 3 lines in a row. Or I can say that some angles are congruent to each other and use a converse theorem. Okay. So, since I know that lines C and D are parallel, what angle is congruent to angle 7? 5. Angle 5. So 2, angle 5 is congruent to angle 7, right? Because these are corresponding angles. Now, I can't say angle 5 is congruent to angle 1 for that same reason, because we do not know that lines A and B are parallel. We're trying to prove that. But I can say angle 5 is congruent to angle 1 because of what? Well, no, if angle 7 is congruent to both 1 and 5, then 1 and 5 have to be together because of the transitive property. Angle 1 is congruent to angle 5 because they're both congruent to angle 7, and that is the transitive property. We use this a lot. Now, because angle 1 and 5 are congruent, we can say lines A and B are parallel because that corresponding angle is converse. All right. Could we have done a different way? Yeah, we could have said that 4 and 7 are congruent and use alternate interior angles instead of corresponding. And 1 and 4 would be again congruent because transitive. And then lines be parallel because of the alternate interior angles. But yeah, we could have used a different angle and used different reasons. There's more than one about a lot. Okay. We could have said that well, that probably would have been very helpful. 6 and 7. Supplementary. We could have said 1 and 3. No, we could say 1. We could say 1 and 3 are corresponding, and then 3 and 7. So yeah, we could have gone several different ways here. It just depends on how you do things. All right. So we are given that J is parallel to K. That's all we are given. Okay. Now, 1 and 7 are not connected in any immediate angle relationship. Okay, they're not same side exterior, same side interior. They're not alternate interior. They're not corresponding. Not really much each other. Now, we do know that angle 7 is supplementary to what angle? Angle 3 and angle 6. So either way, you could go either way. All right, why is angle 7 supplementary to angle 3? Because they're a linear pair. Why is angle 7 supplementary to angle 6? Same side interior angles. Either way will get you what you need. All right, because why is angle 1 congruent to angle 3? They're corresponding. Why is angle 1 congruent to angle 6? They're vertical. And congruent angles are supplementary to the same angle. And that's really all we need. So we could have gone several routes. We could have said angle 7 and 4 are congruent. And we know that angle 1 and 4 are supplementary, which means angle 1 and 7 will be supplementary. So many ways we could have done this. Just depends on which angle you look at, what makes sense to you, what's easier for you to recognize. All right, let's go with angle 3 here. So to angle 7 and angle 3 are supplementary because they form a linear pair. Okay. 3, angle 1 is congruent to angle 3 because they are corresponding. And then 4, angle 1 and angle 7 supplementary because congruent angles are supplementary to the same angle.
Did you just do transit property on them?
Not for supplementary. The transit property only works with congruency. Good question. So, now, the reason why this has so many lines is because for some reason the person who made this wants you to show that angle 3 and 7 add up to 180, and then say that 1 and 3 are congruent, and then say 1 and 3 are equal. So you can substitute 1 and 3 that angle 7 and 1 now add up to 180, and then by definition supplementary. But it makes no sense to do that. Okay? Because honestly, if we know 7 and 3 are supplementary and 1 and 3 are correct, we know 1 and 7 are supplementary because congruent angles must be supplementary to the same angle. Okay? If one's supplementary to that angle, then every congruent angle is also supplementary to that angle. There's no point in going through all those extra steps. Okay? All right. Here we have no numbers and letters. We're going to get good practice on using your angle names here. Okay? So something people tend to forget is how to name angles because we don't do it after a while. Yeah. So one, we're given an AB line segment AB, line A is parallel to line CD. And we're given the measure of angle ABC is equal to the measure of ABC. We're given. So ABC, so this angle here and ABC are very cool. Now, that says if they're equal, what do I know about angle ABC and ABC? They're congruent. And that's just definition of congruent. Now, if I want to prove that lines AD is parallel to BC, I need to show that they have either some bonding angles that are congruent, some alternate interior angles that are congruent, alternate exterior angles that are congruent. But being that ADC and ABC are both interior to both lines, I'm probably going to either use corresponding or alternate. Okay. So, what else, given that AB is parallel to CD, what angles can I say are congruent? Make it easier. What angle is congruent to also congruent to angle ABC? Because lines AB and BC are parallel. Not really a way they can. Yeah. They really restrict us on this. We can't get to do that. I was trying to go with this route that these two angles are congruent because they're all superior, which would be true. But what's the name of that angle? I mean, it is obtuse, but I don't have a name for it because I don't have any other letters. Okay. So I'm probably not going to go with a congruence. I'm probably going to go with supplementary because I can name this angle here. So why is BCD supplementary to ABC? Angle ABC and angle BCD are supplementary. So why is that? Why are these two, when they're not congruent, why is this angle here, right, supplementary to ABC? What kind of angles are there? Same side, interior, converse. No, not converse. Supplementary. Converse, we're trying to prove lines parallel. I'd say there's something. Now, if ABC and BCD are supplementary and ABC is congruent to ABC, then I can state for that angle ABC and angle BCD are supplementary because congruent angles are supplementary to the same angle. Again, I just write out what that meaning. It is called the, I think, supplementary angle congruence theorem, or supplementary angle congruence theorem. That one goes forwards and backwards. If two angles are supplementary to the same angle, they're congruent. If two angles are congruent, they're supplementary to the same angle. That's a biconditional statement. So it works forwards and backwards. Now that I know that angle ADC and ABCD are supplementary, why can I say that 5 lines AD and BC are parallel? And that is because of the same side interior converse. So again, with the proofs, look at what you're given, what you can use with your given, look at the diagram, what you can use with your diagram, and look at the proof and think, what are my only ways I can prove that these lines are parallel? One of the only ways I can prove that these are congruent. They kind of go backwards from there. Alright. So, okay. Number one, we are given that R is parallel to S. We are given that S is parallel to T. One, given. We are trying to prove that angles 6 and 7 are congruent. Now, what kind of relationship does angle 6 and 7 have? Same side interior, same side exterior, corresponding, alternate interior, whatever. Alternate exterior. Now, I could say that they're congruent because their alternate exterior angles are congruent, but that would mean I need to know that R is parallel to P. Do I know that R is parallel to P? I mean, I do, but why do I know R is parallel to T? Yep. So 2, R is parallel to T because the transitive property of parallel lines. Now, usually when you just say transitive property, that's dealing with congruence or equals. So transitive property. But if you're dealing with parallel lines, you do need to say transitive property of parallel lines. Now, that would give us that angle 6 is congruent to angle 7 because they are alternate exterior angles. All right, try number 9. Try number 9.
At this time, we are ready to take any students with the last name beginning with through F. The auditorium, if you need a picture retake. That's D through F. Thank you.
All right, again, look at what you're given. 5 and 16 are supplementary. Right. And we're given 2 and 18 are congruent. We're trying to prove that Q is parallel to R. Right. Now, if we're given that 5 and 16 are supplementary, what lines can we say are parallel because of the fact that those two angles are supplementary? B and Q. 5 and 16 are connected by a transversal T. Lines in Q are intersected, creating same side exterior angles that are congruent. So in that same side exterior angle converse theorem, we can say P and Q are parallel. So that same side exterior angle converse, we can say that P is parallel to Q. Okay. Now 3, we're given 2 and 18 are congruent. Now what lines can we say are parallel to 2 and 18? They're connected by a transversal S. The lines intersected are P and R. P is parallel to R. Because those two angles are corresponding. Now, if P is parallel to Q and P is parallel to R, Q must be parallel to R because that transitive property of parallel line. Number 10, angles 1 and 7 are supplementary. Again, 1 and 7 do not have any direct relationship, but we can use that information to say that some other angles are congruent because they're both supplementary to the same angle. Okay. Or another set of angles are supplementary because congruent angles are supplementary to the same angle. Yeah, either way, we're going to use that concept that the supplementary congruence theorem. Either two angles are congruent because they're both supplementary to the same angles, or two angles are supplementary because congruent angles are supplementary to the same angle. So, see here. We know that the very first one we had, pretty much the same. Up here. Same question. You're given 4 and 7 are supplementary, so prove lines are parallel. Same question. 1 and 7 are supplementary, so lines are parallel. So, I think we went last time with what? Angle 74. So let's go at 7 and 8. And 1, well, we do have to take the other. Angle 1 and angle 7 are supplementary. Given. We can say that angle 7 and 8 are supplementary. Because they are a linear pair. 3, if they're both two angles supplementary to the same angle, then angle 1 is congruent to angle 8. And again, that concept. Angles supplementary to the same angle are congruent. Write that, clearly better. So angles supplementary the same angle are congruent. Which means we know that A is parallel to B because of the alternate exterior angles converse. Again, we could have gone several ways with this. We could set angle 4 and 7 are congruent because they're vertical angles. And then angle 1, 4 supplementary because congruent angles are supplementary at the same angle. Yes.
These for something isn't parallel.
If you want to prove something isn't parallel, you would probably use what's called the indirect proof, which is to basically assume, you start with an assumption that the lines are parallel until you reach a contradiction. Okay. So, if we're in fact given that angle 1 and 3 are supplementary, instead of congruent, then we, assuming lines are parallel, we would reach that contradiction real quick, because 1 and 3 would have to be congruent instead of something. So that's kind of the concept. In order to prove something that's not something else, you would kind of go a roundabout way. And that involves writing a paragraph. I don't think we're going to do indirect proofs. Okay. I mean, not that I don't enjoy indirect proofs, but time-wise and all the other stuff we did in this class, which is not something we covered. All right, so we are given that WT is parallel to X and V. WT parallel to X and V. All right, and we're given that angle XWT is congruent to angle VBR. All right. So we're trying to prove that XY is parallel to VZ. All right. Now, again, concept is in order to prove lines are parallel, we are going to need either some supplementary angles or some congruent angles. Okay. Now I do know that these two lines are parallel, so I can say that angle XWT is congruent to BXY, this angle here, because they are corresponding angles. Right. Which by the transitive property would give me that angle VXY is congruent to angle ZR. And because these are corresponding angles that I've just proven were congruent, that XY is parallel to BZ. Because corresponding angles converse. Number 12, we are given that JL bisects angle NAH. And we're also given that JL is parallel to FI. Parallel lines here. Now, anytime we're given something's bisected, an angle is bisected, we are going to use definition of angle bisector. Now, what does definition of angle bisector say? If we know that JL bisects angle NKH, we can say that angle 1 is congruent to angle 2 by definition of angle bisector. Now, we just showed that angle 1 is congruent to angle 2. We're trying to prove that angle 1 is congruent to angle 4. So, can I prove that angle 2 is congruent to angle 4? and use that transform? Yeah. Why is angle 2 congruent to angle 4? 2 is congruent to angle 4 because these lines are parallel. So the corresponding angles are congruent. And then by the transitive property, angle 1 is congruent to angle 4. I don't know why.
At this time, we are ready for any students with the last name beginning with G through I. If you need to have your picture taken, please head to the auditorium at this time. That is any student with the last name beginning with G through I. Thank you.
I don't know why they need so many lines here. All right. Last one. We're given that P is parallel to Q and L is parallel to W. So lines, different set of parallel lines. Trying to prove that angle 2 is congruent to angle 5. And again, I cannot automatically, there's no transversal, no line connecting 2 and 5. But I can prove that 2 is congruent to angle 3 and 5 is congruent to angle 3. So why is angle 2 congruent to angle 3? They're also interior. Alternate interior angles are congruent. And why is angle 5 congruent to angle 3? Responding it. So that means that angle 2 is congruent to angle 5. No transient property. That's the end of the one. So, go ahead and get started with homework. A lot of stuff left. Yes, get started with it.